Beneath the familiar glow of the night sky, the human gaze has always stretched toward the unknown. Stars scatter like ancient embers, distant yet intimate, woven into the same fabric that cradles the earth. And yet, beyond their silent shimmer, lies a veil, a frontier as intangible as a dream, the edge of the universe itself. For as long as minds could wander, horizons defined the limits of reality. Once oceans were thought endless, their farthest reaches falling into shadow and myth. Maps ended with dragons, worlds collapsed into the divine unknown. But every horizon crossed revealed new lands, new worlds, new truths. Each step forward shifted the boundary between the known and the unknowable. Now, the last horizon is no longer of seas or continents, but of the cosmos itself. Beyond the farthest galaxy, past the faintest whispers of light, space itself fades into a darkness we cannot penetrate. Astronomers call this the observable universe, a sphere wrapped around us like a cosmic cocoon. Within it, every galaxy, every star, every echo of creation we can measure. Beyond it, silence, not because nothing exists, but because light has not had time to arrive. And here lies the most haunting question of all. If our universe has an edge, what truly lies on the other side? Is it simply more of the same endless galaxies, hidden forever beyond our sight? Or does the boundary conceal something stranger, another universe, another reality, perhaps even the end of space itself? The mystery is not only scientific but profoundly human. To confront it is to stand at the shore of infinity, torn between wonder and terror. For beyond the horizon may lie the answers to everything, or the realization that some truths were never meant to be seen, long before the language of physics. Long before mathematics could trace the arc of planets across the heavens, human beings gazed upward and asked the oldest of questions: where does it end? To the first storytellers, the night sky was not infinite but enclosed, a dome hammered from celestial metal or a tapestry stretched by gods. Stars were lanterns, jewels, or fires placed carefully upon that great ceiling. The horizon of the cosmos was a boundary both protective and terrifying, a wall that marked the limits of existence. Beyond it, myths blossomed. Some imagined oceans above the sky, where deities sailed eternal ships. Others believed in infinite layers of heaven stacked upon each other, each world beyond stranger and more radiant than the last. The very shape of the universe was a mirror for the human imagination, revealing not truth but the outlines of our deepest fears and hopes. For millennia, this view endured. The earth stood immovable at the center, and the heavens turned around it in orderly perfection. Aristotle and Ptolemy gave structure to this belief, describing crystalline spheres that held the planets in their paths. To gaze upward was to witness a cosmic architecture, flawless and complete. There was no need for infinity, no need for the terrifying notion of endlessness. The universe was finite, bounded, and certain. Then, centuries later, a quiet revolution began. A Polish cleric named Nicolaus Copernicus proposed a daring heresy. The Earth was not the center, but one planet among many, circling an ordinary star. His model shattered not just astronomy but philosophy. If Earth was not the anchor of creation, then where was the boundary? Suddenly, the cosmos expanded. Galileo's telescope revealed mountains on the moon, countless stars invisible to the naked eye, and the moons of Jupiter dancing in defiance of old models. Each discovery whispered of a universe far larger than imagined, one no longer confined to crystalline spheres. Yet this newfound immensity still carried its own boundaries. In the 17th century, Isaac Newton forged the laws of motion and universal gravitation, unveiling a universe governed not by divine architecture, but by invisible forces. His cosmos was eternal and infinite, a stage stretching without walls in which stars and planets moved forever. To many, this was liberating, an escape from the closed dome of antiquity. But infinity brought its own discomforts. If space had no end, then why was the night sky not ablaze with infinite starlight, every direction filled with suns? This paradox, later named Olbers' paradox, haunted philosophers and astronomers alike. An infinite, static universe seemed beautiful in theory but unsettling in consequence. For centuries, Newton's vision reigned. The stars were eternal, the universe without beginning or boundary. But beneath the certainty, cracks began to form. Observations hinted at subtle mysteries. Galaxies were only just beginning to be catalogued, their nature uncertain, and in the silence of equations, something strange stirred in the early 20th century. Albert Einstein reimagined space itself. His general theory of relativity transformed the universe from a passive stage into a living fabric. Space and time were no longer separate but woven into space-time, curving in response to mass and energy. For the first time, the cosmos could be finite yet unbounded, like the surface of a sphere. A traveler might journey forever without encountering a wall, yet still remain within a closed geometry. Infinity was no longer the only option. The universe could have shape, curvature, and destiny. Einstein, however, faced a dilemma. His equations suggested a dynamic universe, one that could expand or contract. But the prevailing wisdom of the time held that the universe must be eternal and static. To preserve this vision, he introduced a mathematical fix, the constant, a force to balance gravity and hold the cosmos in place. It was elegant, but as history would later reveal, it was also a mistake he would call his greatest blunder. In 1929, Edwin Hubble delivered the evidence that shattered the illusion of stillness. Through the 100-inch Hooker telescope atop Mount Wilson, he measured the light of distant galaxies and discovered something extraordinary. Their light was stretched, shifted toward the red. These galaxies were not fixed in space. They were receding. The farther away they were, the faster they fled. The universe was not static at all. It was expanding. This revelation carried with it an astonishing implication. If galaxies were racing apart today, then in the distant past they must have been closer together. At some moment, long ago, all matter and energy were compressed into a singular beginning. The universe had a birth. The horizon of the cosmos was not merely a matter of distance, but of time. The observable universe became a sphere not because space ended there, but because light could only travel so far since the moment of creation. Beyond that, there was more, perhaps endless more, but hidden from view, locked behind the speed of light and the finite age of everything. With Hubble's discovery, the cosmos became both larger and smaller. Larger because it stretched beyond imagination, with no guarantee of boundaries. Smaller because humanity now occupied a finite bubble of visibility, encased by the speed of light itself. The ancient myths of domes and ceilings had vanished, but the mystery remained. The edge of the universe was no longer a crystal sphere, but a veil of time, a cosmic horizon beyond which we cannot yet see. And with that, the question grew sharper, more profound. If the observable universe is only a portion of reality, then what exists beyond? Is the darkness an emptiness, or does it shimmer with unseen galaxies, forever hidden beyond reach? Science had peeled away the first layer of mystery, only to reveal another. Deeper still, the origins of this discovery marked a transformation. In human thought, no longer was the universe a stage of fixed stars or an infinite expanse without shape. It became something dynamic, alive, bound by time yet open to speculation. The edge of reality was not a wall but a horizon, and horizons, as history has always shown, exist only to be questioned. The discovery of an expanding universe was not greeted with universal acceptance, but with resistance, hesitation, and even ridicule, for the idea of a cosmos with a beginning was as philosophically unsettling as it was scientifically bold. Einstein himself, having reluctantly abandoned his cosmological constant after Hubble's revelations, still wrestled with the implications, uneasy with the thought of a universe that was not eternal. Too many scientists of the early 20th century, the concept of a cosmic birth smacked uncomfortably of religious creation, an intrusion of metaphysics into physics. Fred Hoyle, one of the leading astronomers of the mid-century, gave this theory a dismissive name during a BBC broadcast, calling it the Big Bang, a phrase meant as mockery, yet destined to become its enduring label. Hoyle, instead, championed the steady-state model, a universe eternal in time, forever expanding yet continuously generating new matter to replace what was lost beyond the horizon, ensuring that it remained unchanging on the largest scales. His defiance was not without reason. The philosophical stakes of a beginning were immense, suggesting not only a limit to time, but also the haunting possibility of a reality beyond our observable bubble. Scientists across the globe debated fiercely, torn between models of creation and eternity, their arguments shadowed by the wider ideological battles of the Cold War, where even cosmology seemed to echo questions of origins, purpose, and permanence. Some feared that acknowledging a cosmic birth would lend ammunition to theological claims of divine creation, while others were drawn by the elegance of relativity's implications, willing to accept a beginning if the evidence demanded it. Yet, the uncertainty of what lay beyond the observable horizon lingered, unresolved and unsettling, as if nature itself were teasing humanity with partial glimpses of a truth too vast to grasp. And so the first scientific reactions to the discovery of expansion were not merely technical debates, but deeply human struggles between reason and belief, between comfort and curiosity, between the safety of the eternal and the terror of the finite. The notion of a universe in motion, swelling outward from a single point in time, was as unsettling as it was revolutionary. When the mathematics of general relativity first revealed the possibility of cosmic expansion, Einstein himself resisted the conclusion. His equations implied that the universe could not remain static, that it must either collapse under gravity or expand into something larger. Troubled by the philosophical weight of such an idea, he added an artificial term to his equations: the cosmological constant, a delicate counterbalance to gravity designed to hold the cosmos in equilibrium. It was not a discovery born of evidence, but an intervention born of discomfort. For Einstein, as for many others of his era, the idea of a beginning to the universe suggested a boundary, a limit not only of space, but of metaphysical significance. A cosmos that began was one that might have been created, and for a scientist who sought natural law rather than divine intervention, such implications were profoundly unsettling. When Edwin Hubble's observations of receding galaxies began to ripple through the scientific world, they forced a reckoning. Space was not static, it was alive with motion. Yet even this revelation did not bring harmony. To some, the very idea of a Big Bang, a single explosive beginning, felt absurd. Fred Hoyle, one of the most influential astronomers of the mid-20th century, gave the theory its now famous name, but not as a gesture of respect. On a 1949 BBC radio broadcast, he dismissed it as a ridiculous notion, comparing it to an impossible cosmic firecracker. Hoyle, alongside Thomas Gold and Herman Bondi, championed the steady-state model, a universe eternal in time, constantly renewing itself with the spontaneous creation of matter. In this picture, galaxies drifted apart as Hubble had shown, but new galaxies arose to replace them, preserving the cosmos as a whole in a state of perpetual balance. No beginning, no end, no unsettling boundary, the attraction of the steady state model was not only scientific, but deeply philosophical. It preserved the comforting vision of an eternal universe, one free from the troubling shadow of creation. To many, it felt more dignified, more rational than the alternative. The Big Bang, by contrast, implied a singular moment when time itself had not yet begun, and with it the question that haunted physicists and philosophers alike: what, if anything, lies beyond such a beginning? Could there exist a reality outside our cosmic horizon? Or was the universe all that there ever was, a bubble sealed against comprehension? The discomfort was not unlike that of the ancients, who feared that beyond the map's edge lay monsters. In both cases, the unknown was not merely a matter of science, but of imagination. And imagination often recoils before it dares to venture. The debate over beginnings and eternities did not unfold in a vacuum. It was the mid-20th century, and the world itself was divided, caught in the ideological struggle of the Cold War. Even cosmology was shadowed by these tensions. A universe with a beginning resonated, for some, with theological narratives of creation, an uncomfortable parallel for scientists wary of blending religion with physics. In an era defined by ideological polarization, the steady-state model offered a kind of neutrality, a vision of a cosmos without origin, without dependence on metaphysical interpretation. But the Big Bang, though resisted, continued to gather evidence. The cosmic background radiation, first accidentally discovered in 1965 by Arno Penzias and Robert Wilson, would later become its most decisive proof, the faint afterglow of a universe that once burned hotter and denser than any star, even before that discovery. However, astronomers were uneasy with the very language of horizons and edges. Was the observable universe truly bounded, they asked, or were these limits only artifacts of perception imposed by the finite speed of light and the finite age of time? The thought was unsettling, that reality itself might stretch far beyond what could ever be seen, not because it ended, but because human instruments could never pierce the curtain. The known universe was a bubble, not in the sense of confinement, but of perspective, a sphere drawn by the reach of light across billions of years. Beyond it, something existed, perhaps infinitely more, but it lay outside all possible observation. Hints of this truth emerged in the first deep surveys of the sky. Clusters of galaxies stretched into the distance, their faint smudges suggesting structures beyond any telescope's reach. The universe seemed to whisper of immensity, of realms far beyond sight. Yet each whisper deepened the unease. If the cosmos visible to human eyes was only a fraction, how could anyone claim to understand what lay beyond? The first scientific reactions to Hubble's discovery revealed not only intellectual struggle but existential tremors. Science had unshackled humanity from the false certainty of a static universe, only to replace it with a vision more vast, more terrifying, and more humbling. What became clear in those years was that the question of what lies beyond the horizon was not a peripheral curiosity, but central to the human condition. To acknowledge a beginning was to acknowledge limitation. To accept expansion was to accept mystery. And in that fragile space between evidence and imagination, science itself became a mirror for humanity's deepest anxieties. The universe was not infinite and eternal as once believed, nor was it comfortably bounded by crystalline spheres. It was something stranger, something in motion, something with a past that could be traced but a future that remained hidden. And as scientists wrestled with this new reality, the edges of knowledge itself became as fascinating and as fearsome as the edges of the universe they sought to describe. The debates that followed the revelation of an expanding universe gradually began to shift from philosophical unease to practical investigation. As new instruments opened deeper windows into the cosmos and forced science to confront the very limits of perception. The mid-20th century was an era of discovery shaped by radio astronomy, when vast antennae scanned the heavens for signals invisible to the human eye, capturing whispers of energy that optical telescopes could never see. What they revealed was a universe not only populated by galaxies, but threaded with mysteries, quasars, burning with the brilliance of 1 trillion stars, pulsars ticking like cosmic metronomes, and radio galaxies spewing jets of energy across intergalactic space. Each discovery added weight to the picture of a dynamic, evolving universe. Yet it also amplified the sense that what was visible might be only a fraction of a far larger reality. In 1965, the accidental detection of the cosmic microwave background by Arno Penzias and Robert Wilson offered the most decisive evidence yet for a universe born in fire. Their horn antenna in New Jersey picked up a faint, persistent hiss. A uniform glow spread across the entire sky, to be explained by any earthly interference. This was the echo of creation itself, the cooled remnant of a universe that once blazed at unimaginable temperatures. The discovery shattered the steady-state model and sealed the Big Bang as the dominant paradigm, but it also introduced a profound new horizon. If the cosmos had a beginning, then its observable expanse was limited not by walls of matter, but by the age of time itself. Light from the most distant regions had only just reached Earth after billions of years, and beyond that distance, the universe continued, unseen and perhaps forever unreachable. Astronomers began to map the great architecture of the cosmos, tracing webs of galaxies and voids across space, only to realize that every survey, no matter how vast, revealed merely a sliver of something grander. The observable universe became a phrase of paradox, for it implied not only what could be seen, but also the certainty that far more remained hidden. With each deeper observation, humanity drew closer to the veil of time, closer to the limit where the visible ends and the unknown begins. And yet the mystery of what lies beyond only deepened, as though the universe itself were reminding us that every answer is but a doorway to greater questions. The first attempts to peer beyond the curtain of visible light reshaped the human understanding of the cosmos and began to reveal the hidden scaffolding of the universe itself. In the decades after Hubble's discovery, astronomers reached for new tools, instruments capable of seeing what the eye could not. Radio astronomy emerged as one of the most transformative of these, replacing fragile lenses with vast metal dishes that could capture the faintest whispers from space, where optical telescopes saw only pinpoints of starlight. Radio antennas unveiled phenomena that defied imagination: quasars blazing at the edge of the universe, emitting more energy than entire galaxies. Pulsars, the collapsed hearts of dead stars, flashing with the precision of cosmic clocks. And radio galaxies stretching jets of matter across millions of light years. Each of these discoveries hinted that the universe was not only larger than previously imagined, but also stranger, filled with objects invisible to ordinary sight. And yet, the deeper astronomers probed, the clearer it became that the cosmos was defined not only by what could be observed, but also by the limits of observation itself. The most transformative discovery arrived not through the deliberate pursuit of distant galaxies, but through an accident. In 1965, Arno Penzias and Robert Wilson, working with a horn-shaped radio antenna in New Jersey, struggled to eliminate a persistent background noise that clung stubbornly to their measurements. They cleaned the antenna, adjusted its systems, even chased away pigeons nesting inside, but the faint hiss remained, constant and uniform no matter where they pointed the instrument. What they had stumbled upon was the most ancient light in existence, the cosmic microwave background, a relic radiation from the birth of the universe. This faint glow, spread evenly across the sky, was the cooled remnant of an early cosmos that once blazed at temperatures of billions of degrees, a universe young, dense, and filled with a primordial fire. The discovery was not merely evidence, but proof. The steady-state model collapsed, and the Big Bang became the central narrative of cosmic origins. The universe had not always been as it is now. It had a beginning, a childhood, and a story written in light. The existence of the cosmic microwave background redefined what the phrase "the other side of the universe" meant. It was no longer only a question of what lay beyond the farthest galaxies, but of what existed before galaxies themselves were born. The CMB was a veil of time, the moment beyond which the universe was opaque, when light could not travel freely. To look upon it was to see the edge of the observable past, a boundary not of space but of physics. Beyond that glowing horizon lay a reality forever hidden, the unlit age before light, the very moment of the Big Bang, and whatever, if anything, preceded it. Armed with this new knowledge, astronomers began to map the universe with unprecedented ambition. The first great cosmic surveys charted the distribution of galaxies across immense volumes of space. What they uncovered was a cosmic web, a vast interconnected structure of filaments and voids stretching for hundreds of millions of light-years. Galaxies did not scatter randomly, but clung to invisible scaffolding, their arrangements shaped by the pull of dark matter and the echoes of ancient fluctuations frozen in the CMB itself. These maps revealed that the universe was not merely a scattered collection of galaxies, but a grand architecture, an immense pattern that spoke of forces deeper than sight. Yet even these immense maps were bounded, cut short by the speed of light and the age of the cosmos. Beyond the edge of the observable sphere, the web continues, unbroken, vanishing into darkness. Thus emerged the profound concept of the observable universe, a sphere nearly 93 billion light-years across, containing all the galaxies, stars, and structures from which light has reached us since the beginning of time. But this sphere was not the universe itself, only the part visible to human instruments. Beyond it, the cosmos likely stretches on, perhaps infinitely, yet forever hidden. The realization carried both awe and unease. On one hand, it placed humanity within a measurable context, surrounded by billions of galaxies, each a swirling system of stars and planets. On the other, It reminded us of incompleteness, that everything seen, no matter how vast, might be only a fraction of what truly exists. The horizon of knowledge had shifted outward, but a horizon remained. The universe had revealed more of its face, only to remind us that most of it lies forever beyond reach. With the horizon of the observable universe defined, the next chapter in humanity's cosmic quest unfolded through breakthroughs that pushed the boundary of sight further than ever before. Telescopes evolved into leviathans of glass and steel, their mirrors widening like liquid eyes turned skyward, while detectors grew sensitive enough to count single photons that had traveled billions of years. The Hubble Space Telescope, launched in 1990, became a sentinel above Earth's atmosphere, freed from the distortions of air and weather. Its gaze reached deeper than any human eye had dared, capturing galaxies not as they are now, but as they were when the first stars ignited in the young universe. The Hubble Deep Field, assembled from days of staring at an apparently empty patch of sky, revealed a cathedral of galaxies thousands upon thousands, each one a swirling island of stars. What seemed void was in fact overflowing, a revelation that turned emptiness into abundance and reminded us that every corner of the universe may conceal wonders unseen. Yet, even with this clarity, the universe refused to yield its full truth. As measurements grew sharper, new mysteries surfaced. Observations of distant supernova in the late 1990s revealed that galaxies were not merely drifting apart, but accelerating away, as though an invisible force was stretching space itself. This revelation of dark energy transformed cosmology. The universe was not just expanding, but speeding into a future where distant galaxies would slip beyond sight, vanishing over the cosmic horizon. The familiar idea of an infinite, timeless cosmos gave way to something more fragile, a universe with a beginning, with limits, and perhaps with an eventual end. Each observation, no matter how profound, drew a sharper outline around the edges of knowledge, but those edges only emphasized the vast ocean that lay beyond them. What had once been a comforting darkness filled with stars had become an abyss filled with questions, where every answer pulled humanity closer to confronting the most haunting mystery of all. If the observable universe is but a fragment, what lies outside the sphere of light in the endless night we cannot see? The great silence of the cosmos was not truly silent. It hummed with a faint echo, a whisper from the dawn of time itself. In 1992, the COBE satellite revealed what Penzias and Wilson had stumbled upon decades earlier. The afterglow of creation was not uniform, but mottled with subtle fluctuations, microscopic ripples of temperature, mere millionths of a degree. These imperfections were not flaws, but the fingerprints of destiny. From them would grow every galaxy, every star, every world that would ever exist. What appeared as faint blotches on COBE's crude maps were the first contours of the universe's grand architecture. WMAP would follow, sharpening the picture into extraordinary clarity, and Planck, with its precision unmatched, revealed the infant universe with breathtaking detail, showing that all of cosmic history was written in those tiny fluctuations of light. Within those patterns lay the seeds of the vast cosmic web, filaments of galaxies stretched across billions of light years, separated by voids larger than imagination could easily contain. From almost nothing, the richness of everything but woven into these discoveries was a revelation even more unsettling. The visible cosmos was only a fraction of the whole. Galaxies spun too quickly for their stars to be held by gravity alone. hinting at vast halos of unseen matter wrapping them like invisible cocoons. This dark matter, outweighing all visible stars and gas, revealed a hidden scaffolding, a ghostly framework upon which the luminous universe was merely draped. And darker still was the force that would rewrite everything, the discovery that the expansion of the universe was accelerating, like a balloon not merely swelling, but pushed outward by some unseen hand. Space-time itself was stretching at an ever faster pace. This dark energy was no minor detail, it was the dominant actor on the cosmic stage, dictating the fate of everything. The observable universe became not just a sphere of light defined by distance, but a horizon defined by time itself. Beyond it, galaxies would vanish forever, not because they ceased to exist, but because their light would never reach us. The metaphor grew unavoidable. Just as a black hole hides what lies within its horizon, so too does the universe conceal what lies beyond its own. Humanity found itself living inside a kind of cosmic bubble, watching as the edges grew fainter, the unknown pressing ever closer, reminding us that most of reality is hidden, and that the deepest truths of existence may forever lie just beyond the horizon. The universe, once imagined as an eternal and unchanging backdrop, was now revealed to be alive with motion, tension, and mystery. The maps drawn by Kobe, WMAP, and Planck were more than scientific achievements. They were portraits of a child universe, snapshots of the cosmos in its first breaths, carrying within them the story of all that would come after. Yet, behind the elegance of those images lay a growing unease, for every answer brought with it deeper questions. The ripples in the cosmic microwave background explained how galaxies could form, but why did those ripples exist at all? The mathematics pointed back to an earlier chapter, a fraction of a second after the Big Bang, when the universe is thought to have inflated at a speed beyond comprehension, smoothing and stretching the fabric of reality in an instant. This theory of cosmic inflation was bold, audacious, and haunting in its implications, for it suggested that our universe may not be the only one, that beyond our horizon there could be countless others, each born from similar inflations, each unreachable, each sealed off by its own horizon of light. And while humanity looked outward, what it found was a paradox. Dark matter, though unseen, revealed itself through its pull, as though the cosmos were constructed upon a skeleton of shadow. Without it, galaxies would tear themselves apart, stars would drift aimlessly into the void, and the great structures of the universe would never have formed. Yet no experiment on Earth, no detector buried deep underground or beneath Antarctic ice, has ever captured even a whisper of a dark matter particle. It remains a phantom, known only by its gravitational embrace. Dark energy, by contrast, cannot even be described as matter at all. It is not a thing, but a property of space itself, pressure that drives galaxies apart with ever-increasing speed, discovered in the late 1990s through the dimming light of distant supernova. It was a revelation so startling that it seemed almost absurd, rather than slowing down under gravity's pull. The universe was racing faster into the abyss. This acceleration implies a future horizon, a cosmic boundary that grows more restrictive with each passing billion years. Beyond that horizon, galaxies will vanish one by one, their light stretched into invisibility, until the universe we know becomes a lonely island of stars adrift in a sea of silence. To contemplate this is to confront the fragility of human perception. The universe we see, magnificent as it appears, is but a sliver of reality. confined to the portion of space whose light has had time to reach us. Beyond the observable limit, there may be trillions of galaxies already lost to us, their stories untold, their starlight extinguished by the expansion of space. It forces the mind into uneasy reflection. What is more terrifying, that the universe may have an edge, or that it may stretch on forever, containing infinities beyond infinities, unreachable and unknowable? In this tension lies the power of modern cosmology, a science that does not dispel mystery but deepens it, showing us that every map we draw of the cosmos is less a final chart and more a reminder that we are still standing at the shoreline of an ocean with no visible end. The discovery of the accelerating universe was not merely a scientific milestone. It was a philosophical wound, a revelation that stretched human imagination to its breaking point. Once, the cosmos was thought to expand like the ripples of a stone cast into water, slowing gradually as gravity tugged upon the galaxies. But the faint glow of distant supernova revealed a truth far stranger. Instead of decelerating, the universe was rushing outward with increasing speed, as though driven by an invisible wind that grew stronger with time. The galaxies that had seemed eternal companions in the night sky were now understood to be fugitives, each fleeing not by choice but by the very geometry of space itself. In the far future, their light will fade beyond the limits of perception, leaving only darkness where once there had been constellations. The concept of the cosmic horizon crystallized in the wake of this discovery, just as a ship at sea can never reach the line where the sky touches water. Humanity gazes at a horizon that recedes forever. Today, the observable universe is a sphere roughly 93 billion light-years across, a vast arena filled with 2 trillion galaxies or more. Yet this is not the whole, but only the portion from which light has managed to arrive since the dawn of time. Beyond that boundary lies an expanse far greater, a realm of galaxies whose light will never reach us, no matter how long we wait. The expansion itself stretches their signals into silence, exiling them into a darkness that no telescope can penetrate. It is not simply that they are too far. It is that the universe itself conspires to hide them from view, pulling them beyond the fabric of KNOWABILITY. This realization changed the very meaning of existence within the cosmos. For the first time, astronomers understood that what they could see was a vanishing fraction of reality, that each passing billion years steals more of the universe away from human eyes. The curtain of the observable grows heavier, thicker, more impenetrable, even as technology sharpens and instruments evolve. What the Webb telescope peers at today's the earliest galaxies, the faintest smears of primordial light may, in some unimaginable future, no longer even be visible to those who follow. The cosmic stage is not only vast but in motion, its scenery dissolving and slipping away into permanent exile. And so the mystery deepens. If the known universe, immense as it is, amounts to only a fragment of the whole, what lies beyond the boundary? Some models suggest that for every galaxy seen, countless more exist in the unobservable expanse, perhaps trillions upon trillions of stellar systems burning in unreachable silence. The structures we map, the filaments of galaxies, the vast voids stretching like caverns of emptiness may be nothing more than a small patch on an infinite quilt, a local pattern in a cosmos whose true scale dwarfs comprehension. To contemplate this is to stand again on the ancient shore, staring at an endless ocean, watching the horizon recede no matter how far one sails. Humanity is both discoverer and prisoner, confined to a finite bubble of light while suspecting a vastness beyond all imagining. The thought is humbling, even unsettling, but it carries with it a strange poetry. For in recognizing that the universe is larger than what can ever be seen, science brushes against the very edge of philosophy, where knowledge gives way to wonder. The cosmos, it seems, is not a puzzle to be solved, but a mystery to be entered, a boundless expanse where every answer opens another horizon, and every horizon reveals how much more there is that will forever remain beyond reach. The revelation of the accelerating universe soon carried with it another implication, one even more haunting than the fading of galaxies. If expansion continues to quicken, then the cosmic horizon is not a fixed frontier but a shrinking one, at least in terms of accessibility. Objects that can be seen today, their light barely reaching our telescopes after journeys of billions of years, may tomorrow slip irreversibly beyond reach. The light arriving now is ancient history, a whisper of what once was. But the galaxies themselves are not where they appear. They are already rushing away faster than the light they send. The stars visible in our deepest maps may have already disappeared from our accessible reality, leaving behind only a fading echo. It is as though the universe itself is gradually erasing its own past, pulling a curtain across the stage before the performance is complete. This horizon, sometimes called the cosmic event horizon, is a boundary not of matter but of knowledge. Just as nothing can escape the event horizon of a black hole, so too nothing beyond this cosmic limit can ever influence us. In both cases, there is no wall, no edge, no sudden cliff in space, only a mathematical frontier drawn not in stone, but in space-time itself. It is a boundary woven from the expansion of the universe, a reminder that the cosmos is not simply vast, but also dynamic, slipping away in a silent acceleration that defies intuition. Every year, every century, more galaxies cross that invisible line, lost forever from our cosmic address book. The scale of this unobservable universe dwarfs the human imagination. Astronomers estimate that while 2 trillion galaxies lie within our observable reach, there may be vastly more outside, perhaps 10 times, perhaps 100 times as many. Each one would be filled with billions of stars, countless planets, and the possibility of life entirely beyond our horizon. Yet to us, they are like stories never told, books never opened, worlds never visited. They exist, but not for us. Their light will never brush against the mirrors of our telescopes. Their histories will never be written in our sky. For all practical purposes, they are shadows beyond a curtain of silence. The emotional weight of this discovery is not easily dismissed. For centuries, the stars represented permanence, a map that could be trusted. The constellations seemed eternal, companions, their patterns guiding sailors across seas and civilizations through time. But now it is known that even the constellations are fleeting illusions. The stars of Orion will scatter. The galaxies of the local group will merge, bound by gravity, while the rest of the universe slips away. Far in the future, when expansion has stretched space-time to such extremes that only the Milky Way's descendants remain visible, observers will be left with a sky emptied of all but local light. For them, the story of a vast, expanding universe will be hidden, erased by time, as though the cosmos itself had chosen to conceal its origins. This vision of the future evokes both melancholy and awe. The universe is like an ocean whose tides carry entire continents of galaxies beyond sight. To live in this moment, when the cosmic map is still wide, when the faint whispers of the Big Bang still reach us, is to stand at a rare vantage point in cosmic history. The faint microwave background, the distant quasars, the ancient galaxies glowing faintly at the edge of visibility, these are gifts of timing, available only now, only here, only for a sliver of eternity. In another era, this knowledge would be impossible. The universe is not just expanding, it is rewriting its own accessibility, curating what stories can be told, and which must remain forever beyond reach. The deepening mystery of the unobservable universe thus reshapes the human role within it. Once, the Earth was thought to be the center of creation. Later, the solar system was seen as a modest neighborhood in a galaxy among billions. Now, even the observable cosmos itself has been demoted from totality to fragment, from all that exists to a mere glimpse through a shrinking window. Science has not diminished reality. It has magnified its scale beyond comprehension. The known universe is not the full universe. It is a lantern beam cast into a cathedral too vast to ever illuminate in full. And in that endless darkness beyond, there may be structures, galaxies, even entire realms that humanity will never touch, yet which remain as real as the stars above. At the very frontier of human understanding, the universe offers a paradoxical landscape, an edge that may not be an edge at all. The story begins with the Big Bang, that singular eruption of existence nearly 13.8 billion years ago. In classical cosmology, it is described as a singularity, a point where density and temperature reached infinity, where time and space themselves seemed to emerge from nothingness. Yet physicists have long known that the word singularity is less an explanation than a confession, a signpost where the equations of general relativity can no longer carry us forward. At this boundary, mathematics breaks apart, as though the fabric of reality itself resists being pinned down by human logic. What lies before or beyond is not forbidden, but inaccessible, veiled by the limits of current theory. From this unknown emerged one of the most radical ideas in modern cosmology, inflation, proposed to solve puzzles that the standard Big Bang could not: the uniformity of the cosmos, the flatness of space, the absence of magnetic monopoles. Inflation describes an almost inconceivable moment in the first fraction of a second after creation. The universe, smaller than a proton, is thought to have expanded exponentially, doubling its size not once but countless times in less than the blink of an eye. In this fleeting instant, quantum fields drove space itself into hyper-expansion, smoothing the cosmos into the vast, nearly uniform expanse now visible in every direction. Yet inflation also carries with it a startling implication. If it happened once, it may never truly stop. This vision gives rise to the concept of eternal inflation, process in which new regions of spacetime continue to balloon outward endlessly, each one becoming its own universe with its own laws, constants, and perhaps its own versions of physics. Our cosmos, in this picture, is not the whole, but merely a bubble, one frothing sphere in an infinite sea. Beyond the edge of our observable horizon, beyond even the galaxies forever slipping away, there could exist entire realms utterly disconnected from ours, inaccessible not because of distance alone, but because they are separated by expanding walls of space-time itself. In some, stars may never ignite. In others, gravity may fail to form galaxies. And in still others, life may flourish under suns unfamiliar, gazing out at skies we will never know. The mechanism behind this vision arises from quantum fluctuations, the tiny random tremors in the quantum fields that pervade reality. In the laboratory of the early universe, These fluctuations became the seeds of galaxies, the faint anisotropies in the cosmic microwave background. But on scales beyond imagination, the same quantum trembling could cause inflation to continue in some regions while ceasing in others, generating not one cosmos, but a multitude. Each fluctuation gives rise to a new bubble, and each bubble carries a separate fate. The universe, once thought to be a singular creation, becomes instead an eternal blossoming, a cosmic foam stretching forever beyond sight. To grasp this, cosmologists often turn to the analogy of black holes. Within the event, the horizon of a black hole, information is trapped, forever hidden from outside view. The universe itself may function in a similar way. Our cosmic horizon is not a physical wall, yet it behaves as one. It marks the limits of what can ever be known, regardless of how advanced our instruments become. Just as no observer outside a black hole can see beyond its veil, no observer inside our universe can see beyond its cosmic horizon. Knowledge, here, is bounded not by distance, but by the very nature of space-time. The frontier of science becomes less about what exists and more about what can ever be revealed. This reframing of the edge transforms the cosmic mystery into something deeply philosophical. The observable universe so immense, so rich, with galaxies may be nothing more than a droplet in an endless storm. What is seen may not even be typical, but a single outcome among countless possibilities. The horizon, then, is not a doorway to the whole, but a reminder of the fragmentary nature of human perception. The greater reality, if eternal inflation is true, will remain inaccessible, forever beyond reach. In this sense, the edge of science is not an end but a mirror, reflecting back the limitations of human inquiry even as it points to an infinity of unknowns. And yet, in this very limitation lies a kind of poetry. Just as sailors once looked to the horizon of the sea, knowing it concealed lands beyond their journey, so too scientists gaze at the cosmic horizon, aware that what lies beyond will remain unseen, yet no less real. The extreme edge of science is not where the universe ends, it is where our understanding falters, where imagination must take the place of vision, and where knowledge merges with mystery in the vast silence of the unknown. Inflation itself, though deeply mathematical, is rooted in the simplest of questions. Why does the universe look the way it does? When scientists peer across the cosmic microwave background, the faint afterglow of the Big Bang, they see astonishing uniformity. Regions of the sky, separated by billions of light years, possess nearly identical temperatures, as though the entire cosmos had once been in intimate contact. Yet under the standard Big Bang framework, those regions should never have exchanged information, never have shared light or heat, because they were too far apart. This conundrum is known as the horizon problem, and inflation offers a solution. In its earliest moments, the universe was compressed into a minuscule state where every part could indeed influence every other, like particles within a droplet of dew. Then, in a breathless expansion, that tiny state was stretched beyond comprehension, carrying its uniformity across the vastness of space we now observe. But inflation is more than a convenient explanation. It is also a profound shift in how cosmologists conceive reality, for within its equations lies the possibility of multiplicity. If quantum fluctuations can cause inflation to end in one region while continuing in another, the cosmos becomes a patchwork of eternally budding domains. Each patch evolves into its own universe, sealed off from its neighbors by the relentless expansion of space-time. This scenario is sometimes called the multiverse, though the term can be misleading. It does not imply parallel worlds where familiar lives play out again and again, but instead an endless proliferation of cosmic domains, each potentially governed by distinct physical constants. Some may hold no matter at all, collapsing back into nothingness. Others may brim with strange particles and alien chemistries, their stars igniting with different fuels, their galaxies sculpted by laws unknown to ours. Evidence for this radical vision is indirect, yet not entirely absent. The faint ripples etched into the cosmic microwave background, mapped in exquisite detail by COBE, WarMap, and the Planck satellite themselves, fingerprints of quantum fluctuations stretched to cosmic scales by inflation. These fluctuations seeded every galaxy and cluster of galaxies that would later form, turning quantum chance into cosmic structure. That the observable universe carries this pattern so precisely lends weight to the inflationary model, though the deeper implications, such as eternal inflation and the multiverse, remain speculative. Still, the mathematics allows it, and the observations do not forbid it. In science, such harmony between theory and data is a powerful invitation. If the universe is indeed a bubble among many, then our cosmic horizon acquires a new and haunting meaning. It ceases to be the border of all that exists, and instead becomes the border of all that can ever be known. Like the event horizon of a black hole, it is not a tangible barrier but a limit to observation, a curtain beyond which light will never reach us. Galaxies we see today at the edge of detectability are already vanishing, carried beyond the horizon by the accelerating expansion of space. In the far future, their light will fade entirely, leaving only the memory of their existence in ancient starlight. What lies beyond them, the other bubbles, the other domains of eternal inflation, will remain hidden forever. Such a realization alters the very purpose of cosmology. The search for ultimate origins confronts not only the mystery of beginnings, but also the inevitability of horizons. The universe may not offer a single narrative of creation, but an eternal unfolding, where no vantage point reveals the whole. The singularity at the Big Bang may not be a definitive beginning, but the visible crest of deeper processes beyond comprehension, and the cosmic horizon, rather than the edge of reality, may be a mirror reflecting back the finitude of human perception. In this way, the extreme edge of science is as much philosophical as it is physical. It reminds us that knowledge and ignorance are woven together, that the more we discover about the cosmos, the clearer the limits of discovery become. The multiverse, inflation, singularities, these are not only mathematical constructs, but symbols of humanity's attempt to chart a realm it cannot fully enter. They are the poetry of equations, the metaphors of physics, born of evidence yet expanding into mystery. And at this horizon, where fact and speculation converge, science does not diminish wonder. It deepens it, offering a vision of a reality far larger than the fragile island of galaxies we can ever see. From the beginning of cosmology's great pursuit, scientists have wrestled not only with what the universe is, but with what it could be. Beyond the veil of the observable horizon lies a realm that cannot be touched by light, yet the equations of physics permit certain visions to take shape. These are not idle inventions, but disciplined extrapolations, models built on evidence, stretched into the unseen. Among them emerge the leading theories, each one a different portrait of the cosmos, each one offering a different answer to the question of what lies beyond. The simplest picture is also the most immense, an infinite, flat universe, stretching without boundary, Observations of the cosmic microwave background revealed that space is astonishingly close to geometrically flat, with any curvature so subtle that, if it exists at all, it exceeds the reach of current instruments. In such a universe, what lies beyond the horizon is not exotic or foreign, but simply more galaxies, more stars, more vast chains of matter echoing the patterns we see nearby. It is a vision of endless repetition, a cosmic plane where every direction is the same, without edges, without borders, without an ultimate end. Yet another possibility is that the universe is finite, closed upon itself like the surface of a sphere. In this view, there is no outside, no beyond, only curvature that brings space back upon itself. Travel far enough in one direction and, in principle, one could return to the starting point, just as a journey across Earth eventually circles back to its origin. Such a universe would be vast beyond comprehension, yet still finite, a cosmos with no edge, no boundary, but also no infinity. It is a vision at once humbling and strangely intimate, suggesting that the whole might be navigable in principle, though far beyond any practical reach. A third possibility envisions an open universe, infinite not in the flat sense, but in its eternal expansion. Here space-time stretches without end, curvature bending it outward like an infinite saddle. In such a cosmos, galaxies recede forever, the great structures of matter thinning into isolation. The future becomes one of eternal expansion, where energy grows diffuse and stars burn out, leaving only cold embers in a universe without limit but also without renewal. It is a vision not of cycles but of one vast trajectory, unbroken and unreturning beyond. These classical geometries lies inflation, and with it, the possibility of eternal inflation. In this scenario, the universe we see is but a bubble in a far greater sea. Inflation, the rapid expansion that smoothed and stretched the infant cosmos, may not have ended everywhere at once. Instead, quantum fluctuations might have kept it alive in other regions, spawning new universes as bubbles in an endless fractal froth. Some bubbles might resemble ours, filled with galaxies and stars. Others may be strange beyond imagination, governed by different laws of physics, forever hidden behind horizons we can never pierce. It is a vision of abundance on a scale that defies human intuition, a cosmos where creation is not a singular event but an eternal process. Yet there are theories that refuse to see the universe as either static or endlessly multiplying, and instead picture it as cyclical. In these models, the cosmos lives through repeated epochs of expansion and contraction, a heartbeat of creation and collapse. Each cycle gives rise to galaxies, stars, and life, only to be followed by a great compression and then a rebirth. Whether driven by the physics of extra dimensions, quantum gravity, or unknown forces, cyclic models suggest that what lies beyond our horizon may not only be space, but time itself, time repeating, endlessly renewing, forever weaving new universes. From the ashes of the old, through these competing visions, mainstream cosmology remains cautious. No telescope, no satellite, no particle collider can directly reveal what lies beyond the cosmic horizon. The observable universe is all that light allows us to see, and physics may always remain tethered to evidence rather than certainty. Yet within the equations of general relativity, quantum field theory, and cosmological observation, clues emerge, hints of curvature, patterns in the microwave background, the fingerprints of inflation, the shadows of dark energy. Each clue pushes the boundary of imagination a little further, suggesting not only what could lie beyond, but also what may never be known. In this delicate balance between knowledge and mystery, cosmology continues its search. Beyond the horizon, whether infinite flatness, finite curvature, eternal inflation, or cycles without end, lies not just the structure of the universe, but the shape of our own understanding, how far human thought can reach before it touches the edge of the unknowable. Each of these theories, though forged in the language of mathematics and observation, carries with it a profound philosophical echo. The infinite flat universe, for instance, is not merely a sterile calculation of geometry. It is a vision of boundlessness that dissolves the human instinct for closure. To live in such a cosmos is to accept that the horizon is an illusion of scale, not an edge of being. Beyond every boundary lies only more of the same, stretching endlessly, without pattern or finality. For the human mind, shaped by beginnings and endings, by stories with arcs and conclusions, this is a disorienting thought. An infinite plane of galaxies undermines the very notion of cosmic uniqueness, whispering that every structure, every arrangement, may be repeated countless times across distances forever unreachable. In such a universe, even the improbable becomes inevitable, for in an infinity, all possibilities find their place. The closed, finite universe, by contrast, offers a different kind of reflection. Here the cosmos is not endless but whole, curved back upon itself like a pearl without seams. To imagine such a universe is to imagine completeness, a cosmos that contains all within itself, with no outside, no beyond, no place of exile. The metaphor of a great sphere recalls ancient intuitions of perfection, the geometry of circles and cycles long regarded as sacred. And yet, even in this vision, there is humility, for the scale is so vast that any notion of return remains beyond practical hope. The universe may be finite, but it is a finitude, so enormous that, for its inhabitants, it might as well be endless. The closed cosmos suggests harmony, but also confinement and eternal enclosure, where all that exists is forever contained. The open, infinite universe offers something bleaker, a geometry uncurved, yet destined for eternal dispersal. Expansion accelerates, galaxies drift apart, and in the far future, even the most brilliant clusters will dissolve into darkness. Stars burn down to embers, matter decays, and energy spreads so thin it can no longer fuel structure. This is the heat death, the entropy-bound future predicted by the mathematics of thermodynamics. It is not violent, but it is final a universe, not collapsing, not cycling, but fading into silence. For those who seek meaning in continuity, this is a vision of profound melancholy, a cosmos that does not return, but only wanes. Inflation and its eternal extension shift the picture entirely. Instead of a singular destiny, there is an endless blossoming. In this view, the universe we know is a single bubble in an ocean of creation, each fluctuation giving rise to new regions where space itself bursts into being. The multiverse born of eternal inflation is not a single story, but a library of narratives, some resembling our own, others radically foreign. Within this fractal froth of universes, ours is not privileged but incidental, one flower in an infinite field. And here lies perhaps the most dizzying implication of all, that the laws of physics themselves may not be universal, but local, defined by the conditions of each bubble. What we take as immutable constants, gravity, electromagnetism, the speed of light, may be merely features of our cosmic neighborhood, while elsewhere existence follows other rules. This vision stretches science to the limits of speculation, but it remains anchored in the logic of quantum fields and relativity, offering a glimpse into a reality vaster than even infinity itself. The cyclic models return us to rhythm, to recurrence, to a cosmos that is not static nor singular but breathing. In these theories, the Big Bang was not the beginning but only the latest expansion, one phase in an eternal series of births and deaths. The Great Collapse leads not to final destruction but to renewal, a rebirth in which galaxies and stars arise again. For some, this evokes ancient cosmologies, myths of eternal return echoed across cultures. For physics, it suggests a mechanism by which entropy may be reset, a way for the universe to avoid both the silence of heat death and the finality of collapse. Yet here too lies mystery, for the details remain uncertain, the mathematics incomplete. Still, the image endures, a universe not frozen in fate, but forever in motion, pulsing with creation, destruction, and renewal. What unites these visions is not consensus, but a shared acknowledgement of mystery. The horizon is more than a physical boundary. It is a boundary of knowledge itself. Light can carry information only so far, and beyond that, speculation begins. But speculation in science is not fantasy. It is disciplined imagination, tethered to evidence, shaped by theory, always reaching for consistency. And in this reaching, cosmology touches not only the structure of the universe, but the structure of thought itself, testing the limits of what can be known. The universe beyond the horizon may be infinite, finite, open, closed, cyclic, or fractal. It may resemble our own, or differ beyond recognition. It may be bounded by laws that we share, or governed by rules alien to our understanding. But in every scenario, one truth remains constant. The observable universe is only a fragment, a sliver, of a whole that dwarfs comprehension. What lies beyond may never be seen, yet its presence shapes everything, our science, our philosophy, our very sense of place in the cosmos. At the edge of established science lies a territory where imagination and mathematics entwine, where speculation stretches beyond the horizon of observation and ventures into the unknown. Here, the human desire to comprehend the whole of reality confronts the vastness of possibilities. The mainstream theories provide structure, cautious frameworks of what might lie beyond. But in this more daring landscape, ideas emerge that border on the philosophical, the metaphysical, even the dreamlike. Yet they are not mere fantasies. Each arises from attempts to reconcile known physics with the mysteries still unresolved. From quantum fields that defy classical intuition to space-time geometries that whisper of hidden dimensions. It is here, at this speculative frontier, that some of the most provocative visions of the cosmos take shape. One of the most persistent is the multiverse, a reality not singular but manifold. Eternal inflation suggests that space itself may be forever blooming, each fluctuation creating a bubble universe with its own laws and constants. Some bubbles may expand like ours, filled with stars, galaxies, and life. Others may collapse almost as soon as they form, barren and brief. The implication is staggering that what we call the universe is but a single chamber in an endless cathedral. One note in a cosmic symphony too vast for any ear to hear in full. If true, the horizon is not an edge but a veil, concealing a chorus of realities, infinite in number, diverse beyond imagination. The anthropic principle takes root here, suggesting that our cosmos appears fine-tuned, not by necessity, but because, among countless universes, Only a few permit the fragile emergence of observers. Another daring vision comes from brain cosmology, born of string theory's multidimensional fabric. In this picture, our universe is a three-dimensional sheet, a brain, floating within a higher dimensional space known as the bulk. Other brains may drift alongside ours, separated by imperceptible gulfs, yet close in a greater, unseen reality. Their collisions could spark cosmic events as violent as the Big Bang itself, igniting new universes in cascades of energy. To imagine this is to see our cosmos not as an isolated island, but as one ripple among many on a vast higher dimensional ocean. It suggests that the true architecture of reality may be richer than anything visible, a scaffolding of dimensions that shape the destiny of universes. Perhaps more radical still is the holographic principle, an idea born from the paradoxes of black holes. It proposes that the three-dimensional world we inhabit may not be the fundamental layer of reality at all. Instead, every particle, every star, every galaxy might be a projection, an image encoded on a distant boundary. Just as a hologram creates depth from a two-dimensional surface, the cosmos itself may arise from information inscribed at its edge. In this vision, the other side of the universe is not a physical expanse, but a mathematical boundary where all of existence is written. Space and time themselves could be emergent phenomena, shadows cast by a deeper order of information. At the intersection of science and philosophy lies the simulation hypothesis. Here, the cosmic horizon becomes not a limit of light, but of code. The laws of physics appear consistent, elegant, and quantized qualities some interpret as signatures of computation. If reality is a simulation, then the universe may be no more fundamental than a program running on an unfathomably advanced substrate. The outside would not be another universe of matter and energy, but the realm of whatever intelligence devised the simulation. This notion, while unprovable, forces reflection on the nature of observation itself. If every measurement, every particle interaction is a line of code executing perfectly, then the horizon might be not just a physical boundary, but the edge of design. Quantum cosmology, in turn, suggests that the universe itself is subject to the strange indeterminacy of quantum mechanics. Instead of a singular history, reality could branch endlessly, each possibility realized in a vast web of parallel outcomes. Every collapse of a wave function may not erase alternatives, but allow them to exist elsewhere, in worlds alongside ours. If so, the cosmos beyond our horizon might not only be spatially different, but historically divergent, filled with alternate tapestries where events unfolded otherwise. The other side, then, is not just another place, but another version of reality itself. And at the farthest edge of speculation lies the thought that our universe may reside within a black hole. General relativity tells us that the collapse of massive stars leads to singularities, regions where space and time fold in on themselves. Some theorists have suggested that such singularities might not be the end of space-time, but the beginning of another. Our universe could be the interior of a black hole in a parent cosmos, its event horizon the boundary beyond which outside observers can never see. If so, then every black hole within our universe could be a gateway, not to annihilation, but to creation, a seed of new universes blooming beyond our sight. Though these theories drift far from certainty, they serve a deeper purpose. They remind us that the limits of science are not the limits of imagination, and that the quest to understand what lies beyond the horizon requires both rigor and daring. Each speculative vision, multiverse, brain, hologram, simulation, quantum, branching, or black hole cosmology offers a fragment of a greater mosaic. None may be the final answer, but together they reveal the boundless scope of human thought when faced with the ultimate question: what, if anything, exists on the other side of the universe? The speculative frontier of cosmology, though built on fragile scaffolding, is not merely a realm of fantasy. It emerges from the cracks in our current understanding, from equations that hint at unseen dimensions and paradoxes that demand reconciliation. Physicists do not step into this territory lightly. They are led there by puzzles that cannot be ignored, by the mystery of why the constants of nature are what they are, by the enigma of dark energy accelerating cosmic expansion, by the silent question of what came before the first instant. At the boundaries where observation halts, mathematics continues, weaving visions of realities that stretch far beyond the dome of our visible sky. These theories, though daring, serve as testaments to the restless drive of science to press beyond the known, even when the horizon remains opaque. Take the multiverse, for example. It is not born from mere daydreams, but from the mathematics of inflation itself. If inflation occurred once, why not endlessly? The equations do not demand a singular bloom of expansion, but allow for eternal blossoming, with each new bubble forming under conditions as varied as dice rolls in the fabric of reality. In this light, our universe becomes one of countless experiments, an island where the constants align to permit stability and complexity. The staggering implication is that beyond the veil, most universes may be lifeless voids or chaotic maelstroms, while a rare few cradle stars, chemistry, and life. This picture stretches human imagination to its breaking point, for infinity itself is hard to hold in the mind. Yet, it arises naturally from mathematics, leaving scientists to wrestle with whether this grand multiplicity is a physical truth or an abstraction too vast to ever confirm. Brain cosmology, in contrast, does not multiply universes without end, but instead shifts perspective to hidden dimensions. String theory suggests that the particles and forces of our world are vibrations of strings anchored to a brain, a three-dimensional sheet adrift in a higher dimensional sea. What we perceive as empty space might in truth be only a sliver of a larger arena, most of it inaccessible to us. If other brains hover nearby, their presence could be as close as a breath, yet undetectable through any conventional means. Some theories propose that their collisions could unleash explosions of unimaginable energy, birthing universes like ours in showers of creation. In this vision, the cosmos is not a solitary stage, but one performance among many, each curtain rising in dimensions beyond human sight. The other side of the universe could then be not a distant region, but an adjacent brain, a hidden neighbor pressed against our reality, unseen but influential. The holographic principle adds yet another layer of mystery. It is not a theory of multiplication or adjacency, but of illusion. Rooted in black hole physics, it suggests that the total information within a volume of space may be encoded on its boundary. This strange idea implies that everything we see, every event unfolding in 3 dimensions, could be nothing more than a projection, a shadow cast from data inscribed at the universe's edge. If true, the other side of the universe is not beyond in space, but beneath in depth, for the very fabric of reality may be a representation rather than a foundation. Such a vision challenges human intuition, for it collapses the boundary between the real and the symbolic. It whispers that the cosmos may not be a cathedral of matter at all, but a vast tapestry of information, unfolding like light spilling from a hidden source. The simulation hypothesis, though often treated with skepticism, brings a different kind of provocation. It is less about physics and more about the nature of reality itself. The mathematical precision of the laws of nature, their elegance and consistency, invite the question of whether they resemble the rules of a coded system. If so, then the horizon may not be a natural boundary, but a programmed limit, like the edge of a rendered world in a digital landscape. In such a picture, the other side might not even exist as space. It would instead be the realm of whatever intelligence constructed the simulation, a reality more fundamental than the one we inhabit. Though unverifiable, this hypothesis serves to remind that our deepest assumptions that the cosmos is physical, continuous, and absolute may themselves be illusions, constructs framed within limits we cannot see. Quantum cosmology, meanwhile, draws directly from the strange behavior of the quantum world. In this vision, the universe itself is not singular but branching, splitting with every collapse of a wave function. Where uncertainty exists, reality forks, creating parallel outcomes that exist side by side in a greater whole, beyond the cosmic horizon. Then may lie not only regions of space beyond observation, but alternate versions of history itself. In one, galaxies take different shapes. In another, the constants of physics diverge. In yet another, life unfolds along a different path. The other side is thus not distant, but divergent. A mirror not of place but of possibility, and at the very limits of imagination stands the notion of the universe within a black hole. To contemplate this is to invert perspective. Where classical thought sees black holes as devourers of matter, relativity leaves open the possibility that their interiors may not end in nothingness, but open into new spacetimes. If our universe is one such interior, then the event horizon is both a prison and a warmer boundary through which nothing can return, but within which an entire cosmos can grow. Each black hole in our sky, then, may be another universe's beginning, inaccessible to us, yet linked in an infinite chain of creation. The other side of our universe would thus be not emptiness, but ancestry, the silent inheritance of a parent cosmos from which we ourselves emerged. All of these visions, brain, hologram, simulation, quantum branching, black hole cosmogenicists, down on uncertain ground. They are scaffolds of thought, bridges extended toward the unknown without guarantee of reaching solid land. Yet they carry a profound importance, for in exploring them, science confronts its deepest humility, that the universe may be stranger than the mind can conceive. The cosmic horizon remains silent, a wall of light beyond which no signal returns. But within that silence stirs the greatest mystery of all. It is not only a boundary of space, but of knowledge itself, a mirror that reflects back our questions with no promise of answers. And so humanity looks outward, compelled not by certainty, but by the eternal desire to see what lies beyond the veil. In the present age, humanity stands on a fragile ledge of knowledge, staring out at a horizon that both reveals and denies. For centuries, eyes strained against the night sky, aided only by lenses of glass and the patience of imagination. But now, a new generation of instruments has risen, machines of exquisite precision, perched on mountaintops, buried in ice, or drifting in orbit, each designed to wrest secrets from the cosmos. Together, they extend human sight deeper than ever before, pushing against the silent wall that marks the edge of what can be known. Yet, with every discovery, the horizon only grows more mysterious, reminding that beyond the veil lies a reality that may never fully surrender its truths. The James Webb Space Telescope has become the spearhead of this exploration. Its golden mirrors, polished to near perfection, unfold like the petals of a cosmic flower, capturing light that has journeyed for over 13 billion years. With each observation, it peers closer to the dawn of time, glimpsing galaxies forming when the universe was in its infancy. Some appear surprisingly mature, massive and structured far earlier than expected, challenging models of cosmic evolution. Others reveal star nurseries sculpted by radiation and gravity, places where matter first learned to assemble into the engines of light. Webb does more than photograph ancient starlight. It holds open a window into the formative era of the universe, raising questions about whether the story told by cosmology is complete. Each faint photon it records is a messenger from a time before human memory, whispering of conditions that shaped all that would follow. Yet even Webb, with its unparalleled reach, cannot pierce the final barrier, the wall where light itself ceases to carry information, the horizon that guards the first instant of creation. To approach that primordial moment, scientists turn to the oldest light still visible, the cosmic microwave background. It is a faint afterglow, stretched thin across the sky, the relic radiation of the universe's birth fire. Within its delicate fluctuations are imprints of processes that unfolded in the first fractions of a second. Researchers map these patterns with exquisite precision, searching for telltale ripples that inflation the rapid expansion theorized to have ballooned the cosmos from subatomic scales to astronomical vastness might have left behind. Tiny differences in temperature, no, larger than 1 part in 100,000, become signposts pointing toward the earliest events in existence. Future missions aim to detect an even subtler signal, polarization patterns twisted into the background light by primordial gravitational waves, echoes from a time before the stars, before atoms, when the very fabric of space was vibrating with creation's violence. If such signatures are found, they would serve as fingerprints of inflation itself, offering a glimpse into physics that occurred at energies far beyond what any particle accelerator on Earth could achieve. But light alone cannot carry the whole story. The cosmos also trembles, and from those tremors arises another tool, gravitational wave astronomy. Born in the collisions of black holes and neutron stars, these ripples in space-time wash across the universe with unyielding fidelity, unscattered and unabsorbed by intervening matter. Instruments like LIGO and Virgo, their laser beams aligned with near-perfect precision, have already captured these cosmic vibrations, confirming predictions made a century ago by Einstein. Yet scientists now look beyond stellar collisions, toward more subtle signals, the faint background hum of gravitational waves pervading the universe. If detected, this relic symphony could carry information from moments far earlier than light, can reveal even from epochs preceding the Big Bang as conventionally described. In those whispers, physicists hope to find clues about the nature of space-time itself, whether it was born in an instant or emerged from a deeper, more ancient reality. Even as humanity listens for such echoes, it also studies the silent driver of cosmic destiny, dark energy. This unseen force, responsible for the universe's accelerating expansion, remains one of the greatest enigmas in science. Surveys scan millions of galaxies, charting their distribution and motion, trying to discern how dark energy has shaped cosmic history and how it may dictate the future. Will the expansion continue forever, tearing galaxies apart until the night sky goes dark? Or will its strength shift, reversing into a collapse, drawing all back into fire. Instruments like the Dark Energy Survey and upcoming missions such as Euclid and the Nancy Grace Roman Space Telescope strive to answer these questions. Each measurement a step toward understanding the force that writes the universe's fate. Yet dark energy remains elusive, a ghost in the equations, visible only through its effects on the grand architecture of space. To know it fully may require physics, yet undiscovered, truths hidden beyond the horizon of current understanding. Parallel to these observations, supercomputers construct universes of their own. Vast simulations, containing billions of particles and equations, attempt to model the growth of structure across cosmic time. They recreate galaxies, clusters, filaments, and voids, testing whether the laws as understood can indeed give rise to the universe seen through telescopes. These digital cosmoses can be rewound, fast-forwarded, or altered, exploring conditions beyond what observation alone can show. In them, scientists push into regimes forever, out of reach into regions beyond the horizon, where light will never arrive. Though synthetic, these universes serve as laboratories of possibility, suggesting what lies unseen and offering comparisons to guide interpretation of real data. Through this digital lens, humanity glimpses the contours of realities it can never directly observe, confirming or challenging the foundations of cosmology itself. All these efforts, the telescopes unfolding in the vacuum of space, the detectors listening to the trembling of space-time, the maps of galaxies charting invisible forces, the simulations weaving entire universes in Kodar, united by a singular drive to push against the ultimate wall of knowledge. The horizon is not only a physical limit, but a philosophical one. It marks the boundary between the knowable and the unknowable, between what science can measure and what may forever remain hidden. Yet humanity persists, compelled by a curiosity that refuses to be silenced. The instruments may be imperfect, the theories provisional, the interpretations debated, but the endeavor itself stands as a monument to human perseverance. In reaching outward, the species confronts not only the cosmos but itself, facing the paradox of a mind shaped by finite limits, yet striving to comprehend the infinite. The journey is far from over. Webb will continue to gaze deeper. Gravitational wave observatories will grow more sensitive. Dark energy surveys will refine their maps, and simulations will gain complexity. New instruments will rise, each surpassing the last, each daring to peel back another layer of the cosmic shroud. Yet perhaps the greatest revelation is not what these efforts will uncover, but what they reveal about humanity's place. For the horizon, in its silence, is not a wall meant to deny, but a mirror meant to inspire, reminder that existence is vast, mysterious and unfinished, and that the pursuit of knowledge is itself a form of cosmic wonder. The pursuit of these frontiers is not merely a technical undertaking, but an existential act. Each new machine built, each detector tuned to impossible sensitivity, is a quiet declaration that the human mind refuses to accept ignorance as its horizon. In mountain observatories, in frozen Antarctic ice, in silent orbits around Earth, these instruments stand as sentinels of curiosity, each recording signals too faint for ordinary senses, each capturing fragments of the universe's autobiography. There is a certain poetry in their design. Golden mirrors shaped like flowers, lasers stretched across kilometers, lenses chilled to near absolute zero, all fashioned not for beauty alone, but for the discipline of precision, for the fragile chance that a single photon, a single vibration, might carry the imprint of creation itself. The James Webb Telescope, though celebrated for its imagery, is more than an eye. It is a time machine of photons, gathering not only the light of ancient galaxies but their silence, their chemical breath, their elemental fingerprints, the hydrogen and helium that streamed from the first stars, the heavy elements forged in the deaths of suns, the carbon and oxygen destined for planets like Earth all are etched into the spectral web records. In its data lies the story of alchemy on cosmic scales, how the raw ingredients of the void learned to combine into complexity, yet beneath the triumph of its clarity there lingers unease. Some galaxies it reveals appear too massive, too luminous, too mature for the early universe, hinting that cosmology may still be incomplete, that something in the tale of beginnings is missing. The telescope's discoveries, though dazzling, do not close questions, they sharpen them, making the silence beyond more profound. Meanwhile, the faint whisper of the cosmic microwave background endures as the oldest testimony the universe offers. It is a fossil not of stone or bone, but of light itself, afterglow released when the cosmos was scarcely 380,000 years old, long before stars carved brilliance into darkness. Satellites like COBE, WMAP, and Planck have mapped its delicate mottling, each fluctuation a clue to density variations that would one day grow into galaxies. Yet scientists continue to stare into its patterns with unrelenting focus, searching for the subtle twist of polarization that might prove inflation's wild expansion. That signal, so faint it would be nearly indistinguishable from noise, carries the promise of reaching into the first trillionth of a second, into a realm where classical notions of space and time break down. To glimpse such evidence would be to brush against the very mechanism that gave the universe its vastness. The afterglow is not only a relic, it is a map written in a language still only partly understood, a code hinting at dimensions of reality humanity has only begun. To fathom the promise of gravitational wave astronomy extends this pursuit into new territory, where light fades, vibrations endure. When two black holes spiral together, or when neutron stars collide in catastrophic brilliance, they disturb space-time itself, sending ripples outward like concentric circles across a cosmic sea. Already, these signals have confirmed Einstein's predictions, but their potential reaches much further. Instruments in planning, vast detectors floating in space like LISA, could one day hear frequencies impossible to detect on Earth, capturing murmurs from the earliest moments. In those low tones may lie the background chorus of existence, a remnant from times older than light. If the universe once passed through a phase of violent symmetry breaking, or if hidden dimensions shuddered as they unfolded, the evidence may still resonate through space-time, waiting only for instruments sensitive enough to listen. In such discoveries, the line between science and philosophy blurs, for what is revealed is not merely an event, but the architecture of reality itself. Dark energy remains the most haunting enigma of all, invisible, unmeasurable directly. It is discerned only by its effect. Galaxies fleeing faster and faster, acceleration where deceleration was expected. It composes nearly 70% of the cosmos, and yet it has no identity in known physics. The surveys mapping it, the missions designed to measure its equation of state, are acts of defiance against the unknown. Scientists speak of quintessence, of phantom fields, of modifications to gravity itself. Each model tries to tame a mystery that seems determined to elude categorization. Perhaps it is not a substance, but a property of the vacuum. Perhaps it is evidence of multiverses beyond perception. Perhaps it is nothing humanity yet imagines. What is certain is that dark energy holds the script of the universe's destiny. Whether space will expand into eternal cold, or whether an unseen force will someday reverse its pull, all depends on this ghostly phenomenon. To study it is to ask not only how the universe began, but how it will end, and whether endings are final at all. While observations accumulate, simulations with threads between them. In immense data centers, rows of processors hum, recreating the cosmos in silico. These simulations are not mere approximations, but self-consistent universes, evolving under the same laws believed to govern reality. They track the formation of stars, the swirling of gas, the clustering of galaxies, even the growth of supermassive black holes. By comparing them to what telescopes reveal, scientists test the boundaries of theory, probing whether unseen physics must be added. Simulations allow humanity to step beyond observational limits, running experiments that reality itself denies, altering constants, shifting conditions, rewinding creation. In their artificial skies, one can peer into regions beyond the observable, into volumes that no light can ever cross. These synthetic universes, though uninhabited, serve as guides to the real one, illuminating paths through the darkness of ignorance. And so, the instruments, the maps, the equations, the simulations, all converge upon the same horizon, the edge of what can be known. The effort is relentless, the questions unending, the mysteries deepening. Yet this is the essence of science, not a quest for final answers, but a journey through layers of understanding, each peeled back to reveal another. The horizon itself becomes a symbol, a reminder that knowledge is always provisional, that the cosmos is not a riddle to be solved once, but a symphony to be listened to without end. Humanity's tools may grow sharper, its reach more profound, but the wall of mystery will always stand, retreating just as it is approached. And perhaps that is the true gift of exploration, not that the universe will one day be fully known, but that it invites an endless pursuit, an eternal unfolding of wonder. Across the ages, the horizon has stood as a silent teacher. For the first sailors, it was the shimmering line where the ocean kissed sky, a place both feared and longed for, a boundary beyond which monsters were imagined and countenance awaited. For the explorers on horseback, it was the edge of deserts and mountains, the vanishing point of dust and stone where civilizations gave way to wilderness. For stargazers of antiquity, it was the dome of the heavens, the unreachable vault adorned with fire, believed to be the dwelling of gods. Every culture has known this line, the limit of sight, the end of certainty, and yet, time and again, humanity has moved toward it, compelled by something more powerful than fear. The horizon is not simply a distance. It is a mirror reflecting the hunger of the human spirit, the restless insistence that there must always be more. The cosmos itself has now become that horizon, a canvas where physics and imagination converge. Astronomers trace its faintest light, philosophers weigh its mysteries, and poets lend it shape through metaphor. But always the horizon slips further, never granting permanence. In this elusiveness lies its strange power, for it embodies both promise and humility. The questions it asks are not only about galaxies and dark matter, but about the very capacities of the mind that contemplates them. Can a finite consciousness truly comprehend infinity? Can language born from finite experience ever describe the unbounded? Each attempt to cross this cognitive horizon leaves humanity richer, yet still aware of the immeasurable distance that remains. The horizon is thus both frontier and teacher, reminding that to seek truth is not to conquer, but to listen. Fear and wonder are companions at this edge. The other side may conceal truths too vast, too strange for human comprehension. Infinity can be as terrifying as it is majestic, suggesting a cosmos where human life is but a fleeting echo, a spark swallowed in immensity. Yet in equal measure, the horizon evokes hope. It whispers of undiscovered beauty, of connections waiting to be seen, of meaning woven into scales grander than imagination. Perhaps what lies beyond the horizon is unknowable not because it is empty, but because its fullness overwhelms all forms of grasping. This unknowability becomes not a failure, but a kind of poetry, a recognition that existence exceeds measure, and that mystery itself is sacred. The universe, in its vast silence, often serves as a mirror. The galaxies spiraling at impossible distances echo the spirals of human thought, the cycles of birth and death mirrored in the turning of stars. What humanity seeks in the sky erosions patterns. Destiny is often a reflection of what it seeks within: belonging, coherence, continuity. To peer into the cosmic horizon is, in some sense, to peer into the horizon of the self. Every discovery is twofold: an insight into the mechanics of reality, and an unveiling of the desires and limits of those who search. The other side of the horizon, then, may be less a location than a revelation, a place where outer and inner mysteries converge, where the cosmos turns its gaze back upon its observers. In the end, the horizon may not be meant to be crossed at all. Its function is not to yield, but to beckon. Its role is not to give answers, but to sustain questions. To stand at its edge is to participate in an eternal dialogue between the known and the unknown. The horizon does not diminish with each step. It renews itself, inviting humanity into an unending pilgrimage of curiosity. And perhaps this is the deepest truth it offers, that the value of the horizon lies not in what it hides, but in what it awakens the willingness to seek, to imagine, to be humbled, and to hope. Thus the journey concludes, not with resolution, but with an opening. The cosmos remains vast, its other side still veiled, its truths still suspended beyond reach. Yet this is not defeat, it is an invitation. The horizon is not an end, but a promise, a reminder that existence is larger than comprehension, and that to keep looking is itself a form of belonging. In the patient act of gazing outward, humanity finds its place, a species forever drawn to the edges, forever listening for echoes in the silence, forever chasing the shimmer of the horizon.